All right, number one here says find the indefinite integral. So, guys, all we're going to do is integrate this. So, I'm first going to start by rewriting this. All right, as 1/2 x to the -3. All right, I just brought that portion to the top. Now, when I integrate that, that gives me 1/2 times x to the -2 over -2, which becomes plus c. I almost forgot my c, which becomes -1/4 x squared, right there, plus c. All right, so that's number one. Number two, I'm going to rewrite this as 4x to the 2/3. But when I integrate that, that's 4x 2/3 plus 1 is going to be 5/3 divided by 5/3, which we keep change flip. So 3 times 4 is 12 plus c. So you have 12 over 5. I can go cube root again. Of x to the 5th plus c. Oops, not 5, but x to the 5th. Like that. Alright. Now let's look at this one here. Because there's two binomials, guys, you probably need to FOIL that first. Alright, which I would do it. And when you FOIL that up, you're going to get, let's see, x times 3x is 3x squared minus 2 x plus 3x minus 2, which simplifies as 3x squared plus x minus 2 dx. So I integrate that, you get 3x squared or 3x cubed over 3 plus x squared over 2 minus 2x, which when you simplify this, x cubed plus 1/2 x squared. Notice that's not at the bottom. Alright, that's next to it. Minus 2x plus c. Over here, again, just integrate everything. Negative 4z to the -2 divided by -2. Oh, my fault. I got the integration sign still here. There we go. Negative 4z to the -2 over 2 plus 20z to the -4 over -4. So negative 4 divided by 2 is -2, so -2z up. So negative, that is a negative. Let's move that to the bottom. So negative 2 divided by z. Man, I did it again. Sorry, y'all. It's late. I'm sleepy. Negative 4. Oh my gosh. I'm gonna have to edit this. Negative 2 over z squared. Man, it took all that for me to get that. Right here. 20 divided by -4 is -5 divided by z to the 4th. Alright, so there we go. Man, sorry about that. I struggled my way through that one. Oh, plus c. I almost forgot my plus c. Now for this one, we need to rewrite this as the integral I wrote F, man. Hold up, let me zoom in on this. Better give me some more. Alright, right here. We first need to rewrite this, so I'm gonna rewrite this as, let's change the thickness of this. 15x to the negative 4 plus 8x to the negative 5, which we can take the Reimann sign. When we integrate this, we have 15x to the negative 3 divided by negative 3. I'm going to make that a minus. So 8, well, here, plus 8x to the negative 4 divided by negative 4 plus c. So when we simplify this, 15 divided by negative 3 is negative 5. So negative 5 over x cubed. That's negative 2. So minus 2 over x to the 4th plus c. Alright, right here, this is exactly like a problem that was on your quiz that we've kind of been struggling with, and we need to rewrite that. Alright, well, here, let me separate it like this first. T squared over t to the 4th. Alright, anyway, that's 1. T to the 4th divided by t to the 4th is 1. And then t squared over t to the 4th can be rewritten as, or just subtract 4 minus 2. It's 2. So you have 2 t to the negative 2. Alright, because if you just rewrote it like this, 2t squared t to the negative 4. 2 minus 4 is negative 2. Like that. Anyway, when you integrate, you get x minus 2t to the negative 1 over negative 1. So that becomes a positive right there. X, that becomes plus 2 over t to the 1st plus c. Alright. Now, let's go ahead and keep going. Given f of x is 1/2, find a particular solution that satisfies f of 1 equals 0, and then write in f of x form. So this means we got to find c, and then we need to write the actual function when we're done. So we're going to integrate this right here, 1 over x squared, which we can rewrite as x to the negative 2. And then when we integrate that, that's going to give us x to the negative 1 over negative 1 plus c, which is 1 over x, negative 1 over x, excuse me. So anyway, plus c. So now we plug in, we evaluate for 1 because it says f of 1 over here. F of 1, well, x is 1. So we have negative 1 over 1 plus c equals 0. And so that's negative 1 right there. So if I add 1 over, c equals 1. So now that I have c, I'm going to plug it into f of x form. So we have negative 1 over x plus 1. There's our answer right there. Right here, given h of x, or h prime of t is 8t cubed plus 5. Find a particular solution that satisfies h of 1 equals negative 1, and then write in h of x form. So this is the same as that thing. Now we're going to integrate that. 8t cubed plus 5. We integrate it. We get 8t squared. Oh, I'm sorry, to the 4th over 4. Got to add 1, I subtract. Plus 5x plus c. which we can convert that to 2t to the fourth plus 5x plus c. Anywhere we plug in x, well, x is 1, or t. So 2 times 1 to the fourth plus 5 times 1 plus c, and that equals -1. So that's 1 times 2 is 2, plus 5 plus c equals -1. That's 7 plus c equals -1. Subtract that over, c is -8. So now we write our final equation, which was 2t to the fourth plus 5t minus 8. Let's see here. Ooh, didn't mean to move that. For number 9 here, find the cost function, c of x for the marginal cost and fixed cost. Alright, so this is the derivative is 85. So, and c of 0 equals $5,500. So, if we integrate 85 dx, that's going to give us 85x plus c. And so we plug in 0, 85 times 0 plus c equals 5,500. That's 0, so c equals 5,500. So that equation is going to be c of x equals 85x plus 5,500. And that's what you would put on the line. All right. All right, number 10. Number 10, same type of problem. The derivative is 1 over 50x. Hold up, I don't want that to look like it's in the denominator because it's not. Sorry about that. Man, when you can change this thing, you gotta change the thickness back. 1 over 50x plus 10. When we integrate this, again, that's just 1 over 50. And then this becomes x squared, so we have to divide that by 2, plus 10x, plus c. So this right here, this stuff right here becomes x squared over 100, plus 10x, plus c. And now we're going to plug in 1. So 1 squared over 100 plus 10 times 1 plus c equals 2,311. So that's 1 over 100 times 10. 10.01. Hold on, let me see. Plus 10. So 1 over 100 plus 10. Yeah, 10.01. So that's 10.01. 10.01 plus c equals 2,311. And then we just subtract 10.01 over here. So c equals 2,399. So that's c. So now we write our final equation. C of x equals 1 over 100 x squared plus 10x plus 2,399. Alright. Alright. A bowling ball is thrown upward at an initial velocity of 64 feet per second from an initial height of 80 feet. Find the position function given the weight of the function. So remember, guys, man, Earth gravity. I know you're like, man, why do we always start with this value? Oh, computer's about to die. Again, Earth gravity equals negative 32 feet per second. So that's what we always start with. This is a constant that won't change. This is our second derivative. All right, our second derivative. So let's just find a position function given that the height h has a function time, function t times of t time t. Excuse me. So of course we start with the second derivative. We're going to integrate that to find the first derivative. So we integrate negative 32 dx, and when we do that, that's going to give us negative 32x plus c. Alright, so this is the first derivative, which is our velocity. This is the velocity right here. Alright, and they told us what that was, right? The initial velocity was 64 feet. So c is 64. That's our velocity equation right there. And then we need to go ahead and integrate this again. Alright, so when we integrate again, we'll get h of t, or just h of t for the height. So we integrate negative 32x plus 64 dx. That gives us negative 32x squared over 2 plus 64x plus c. And again, this is our height, all right, which was 80. So simplifying this equation, that gives us negative 16x squared plus 64x plus 80. So there's our equation right there, right? Is there a blank over here? Nah. So there's the equation for part A. All right. Now B, it says, when does the bowling ball hit the ground? All right. Well, we set this equal to 0 because the height is 0. And again, man, you can just factor this, to be completely honest, or graph it in your calculator. Excuse me, in your calculator. So, again, negative 16x, 16x squared plus 64 x plus 80, and we graph that. I know this isn't to scale at all, and it really doesn't matter. I know it's gonna be a quadratic. I just need to figure out where this whole thing equals 0. So I'm just gonna adjust this window real quick. Actually, you know what? Let's do this. Let's just press zoom. Zero. Zoom fit. There we go. Zoom fit. Just so I can see the graph. Alright, that's cool with me. It ain't that serious. I just want to see where this graph equals 0, because that's when it hits the ground. So there you go at the table, -1 and 5. Alright, -1 and 5. Alright, or you can use that second trace function as well. Well, let's see if I made this -5 real quick. X max. Made this. Right, you can do the trace function to see it. All right, if you couldn't see it, second trace, 0 is option 2 right there. All right, because sometimes it might not be that clean. So left bound, you have to do this twice. So left bound, I want to move that cursor to the left side of that x-axis. So like negative left bound. See how this line is on the left side of this point, and then right bound just move the cursor to the right side of this point. So see how that's on the right side. So there's -1, 0. All right. And then you do the same thing over for 5, left bound somewhere, right bound somewhere. You get 5. Or again, just look at your table right here. Right there. So -1 and 5. But anyway, though, back to the answer right here. X equals -1 and 5. Which one do we use? Obviously, we use the 5. All right. Don't want the negative. So we have 5 seconds. All right, 5 seconds. Now for, oh wait, do we have, nope, that's it. All right, cool. So now right here it says express the limit as a definite integral. So we're just rewriting this, all right? So rewrite this limit right here. So this would be from the interval 0 to 2 of 1 over 2 minus x cubed. All right. That's the limit right there. dx, sorry. I want to ask you to actually solve this one yet. I haven't taught you substitution, so we're just rewriting these. Your calculator won't integrate that one for you. When in is a partition. All right, so this one, we rewrite this one. So integrate from 5 to 10 of, y'all see this is c to the 8, so x to the 8th dx. All right. Now evaluate the definite integral. This is calculator work. But for the sake of showing work, because remember, you want to show partial because you might punch that in wrong. And if you're wrong, man, the partial might help. So if you integrate this, that's going to be 6x squared divided by 2. And we're going to integrate from -2 to 10. All right, and all you got to show is this for work. And then f of 10 minus f of -2. All right, I'm cool with that. All right, this and this. You show me you integrated it. You show me that you're going to evaluate it from 10 and -2. All right, but anyway, if you went ahead and carry that out, that's 3. That's 3x squared. So you'll have 3 times 10 squared minus 3 times a -2 squared. And so 300 minus 4, -12. So 300 minus 12 is going to be 288. Again, that's work. Integrated. Show me your limits, all right, or your intervals, and then show me you're going to evaluate it from 10 to -2. This one, again, show your integration. -3z squared divided by 2 plus 4x from 1/2 to 5/2. And then show that you're going to evaluate from 5/2 minus 1/2. All right. But anyway, when you evaluate it, 1/2 squared is 1/4. Let your work do it, man. -1. All right, that's it for this page. All right, last page. Let's see here. Same thing. Show your work. We integrated, so this is 1/4. I just need to evaluate x cubed, so x to the 4th divided by 4, which simplifies to be x to the 4th over 16. And from -1 to 3, f of -1, f of 3 minus f of -1, which is 5. This one right here, guys, we have a power. Apply the power to the whole parenthesis first. So x squared over 4. Now integrate this whole thing, dx, sorry. 1/4 x cubed over 3, which simplifies to x cubed over 12 from 0 to 6. F of 6 minus f of 0. And when you evaluate that, you get 18. All right. For each problem, approximate the area under the curve over the interval using 4 sub-intervals. Y equals 2x squared plus 3 from 3 to 0. All right. So first of all, we know n is 3. N is 4. All right. N is 4. Now use right endpoint rectangles. Sketch the graph with the rectangles is in the overestimate or underestimate. So, man, sketch your graph. All right. So we're going from 0 to 3. Oh, man, excuse me. Let me make a quick graph real quick. All right, cool. So we got 0, 1, 2, 3. So real quick, let's find delta x. So 3 minus 0, remember, is a minus b divided by n. So 3 over 4. So we count this thing by 3/4. Each rectangle is 3/4. So if we broke this down into 3/4, let me use 1, 2, 3, 4 is 3/4. All right, 4/4, 5/4, 6/4. 6/4, which is really 3 halves, which is halfway. 7/4, 8/4. So 3/4. We need this one. We need that one. 8/4, 9/4, 10, 11, 12/4 will give us 3. So 6, 7, 8, 9/4. We need that one. And this one. All right. So every 3/4. So let's draw the rectangle. And you really could graph this thing. If you graph it, it increases. So you have something like boom, 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 like that. All right. So anyway, we're looking for the right Reimann sum. So right Reimann sum, the right round. Oops. And remember, you can put this in your calculator because it's an estimation. So remember, for the right Reimann sum, we don't use the left value. All right. We start with the first value right here, 3/4. And we're going to work to 3. Oh, and each step is going to be 3/4. All right, so basically, when you put this in your calculator, it's delta x times f of 3/4 plus f of 6/4 plus f of 9/4 plus f of 3. Which again, we put that in our calculator, so you would do 3/4 delta x times, if you remember the sum of the sequence. All right, and then you just got to hear. We're just gonna do it. Let's do it in the calculator. So quit this. So we got 3/4 times, which is delta x times second stat. We want the sum, and then second stat again. And then we want go over the operations 1/5. Now we have the equation 2x squared plus 3. The variable is x. We're going to start with 3/4. We're going to end with 3. And each step is 3/4. Now, don't forget your step is just delta x. Alright. So there we go. 34.31. Alright, 34.31. So I'm not going to write that out. I'm just going to write it the right round. 34.31. I don't know if it's an over or underestimate yet. I got to actually find the actual one. Is it an over or under? Well, okay, never mind. We're going to do it. So to figure out if it's an over or underestimate, we actually integrate it. All right, so from 0 to 3 to 2x squared plus 3, we integrate that. All right, and when you do that, 2x cubed over 3 plus 3x from 0 to 3. So 0 won't be there. I just need to do 3. So 27, 54 divided by 3. 18 plus 9. 18 plus 9 is 27. So this is an overestimate. This is the actual Reimann sum, guys. If you did that in your calculator, you get 27. Matter of fact, here, let me just show you real quick. Well, no, you got it. You got it. That's the actual interval right there. This is Reimann sum. This is the actual area right there. So it's an overestimate. All right. For 19, let's see the left endpoints. Ooh, let me move that. So we gotta do the left endpoint. So the left round. So using the same graph and counting by 3/4, this time we're gonna start at 0. I'm gonna use the same graph. So 0 to 9/4, we won't use 3. All right, we don't use 3 right there. So delta x times the sum of 0 plus f of 3/4 plus f of 6/4 plus f of 9/4. I just increase by 3. Or if we put it in our calculator again, um, 3/4 times second stat on the sum of second stat operation, hit that sequence. So everything's the same except we're going to start this time at 0 and end at 9/4. Oh, we'll need parentheses right there. And step is still 3/4. When we do that, we got 20.81. 20.81. So we know the actual is 27, so this is an underestimate. Estimate. God dang, can't spell, man. Underestimate. because it's under 27. All right. Now the middle Reimann sum. The middle Reimann sum. I'm gonna go back to that graph. All right. For the middle Reimann sum, we gotta do a little work right here, just cause our values are gonna change. So see how we have these values right here? Let me write them out. I'm actually do this again. Use the number line real quick. You got 0 because it's in 3/4. So we have 3/4, 6/4, 9/4, and 12/4, or 3. All right, that's 12/4. We want half of that. All right, half of that. So half of 3/4 would be 3/8. So you have 3/8 now. We're going to use 3/8. Matter of fact, here, we use the same one. So half of this right here, half of 3/4 is 3/8, right? So this is 3/8. Then we want half of this one. So that's 3/4. So 3/8. We want. So remember, if you remember, our step is still 3/4. So this is 3/8. Just add 3/4 to that. You get 9/8 right here. So halfway is 9/8. If you add 3/4 to that, you get 15/8. So this is 15/8. And then if you add 3/4 to that, you get 21/8. Again, so what I just did was I took 3/4, found half of 3/4, so I multiplied that by 0.5. That's 3/8. All right. So 3/8. If remember, delta x is still 3/4. All right, delta x is 3/4. So if I add 3/4 to that, 3/8 plus 3/4, all right, is 9/8. Plus 3/4 is 15/8. Plus 3/4 is going to be 21/8. Or if you converted this to eighths, right, times 2, so times 2, 6/8. So 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 6 is 21. All right, so those are my midpoint values, okay? So when I do my middle round Reimann sum, it's going to be delta x times the sum of 3/8 plus 9/8, f of 9/8 plus f of 15/8 plus f of 21/8. 21/8. All right. Again, how do I find the middle of these? All right. I took the 3/4, found half of that, which is 3/8. Now I just keep increasing by 3/4 because that's our step. So anyway, when you put this in your calculator, you do the middle round, you only use the middle values. I don't use 0 or 3. I use all the middle values. All right. So to my calculator, same type scenario. We have second, stat, math, sum. Oh, my fault. 3/4. Forgot about 3/4 first. And then we have math, second, stat. Go to math. And then second, stat again. Go to number 5, sequence. And so same equation, variables x. We're going to start this time with 3/8. We're going to end with 21/8. All right, but the step is still 3/4. So we get 26.71. 26.71. equals 26.71. All right. Now, is that, oh, it doesn't ask about over or underestimate, so we're good right there. So now it says 21. This is the middle round. Now it says compare the left round, right round, and the middle round from above values to the actual value. All right. What observations can be made about these values? All right. So again, remember we did the actual one from 0 to 3 of 2x squared plus 3 dx, and we got 27. So we just make conclusions off of that. All right. So we can say that the right round is an overestimate. The left round is an underestimate. All right, and then we can say the middle round. The middle round is the closest approximation to the exact value. Closest. That should be an S. Man, closest approximation. Approximation to the actual, or let's say exact value. All right, so that really concludes, man, this whole thing. Again, this is the exact value. 27. So, and you can just see, man, right round, left round, and this estimate here. I think the hardest thing for y'all is going to be figuring out that middle round. But all you got to do again, all right, like I did right here, if you get your original boxes by 3/4, and then find half of the first one, and then just keep increasing by the same step. So plus 3/4, plus 3/4, plus 3/4, or convert that to eighths. All right, you'll be fine. All right, so don't forget, man, I have tutoring. If you need it, there's tutoring, and the video's up on eClass, but there's tutoring Friday morning if y'all want to come in with additional questions. Catch you later.